Okay. Yes, I'm going to be talking. Settle down. Right. Right. Today we're going to do something a bit different. Uh, okay. I spent a couple of hours this afternoon getting or changing the way top formula were put into the system. I thought what I do now is we're at a point now where I'm reasonably happy that we're on the right track with this developer VM, and I can show you where we're at now and describe what I'm going to do in the future. Okay, so why do all of this? The basic idea is that I want to standardize a working environment for various projects. The idea being that it makes life easier for ad hoc developers to just step in if they've got a standard environment. I am somewhat presupposing that everyone who comes to do these things is working in a Linux environment or knows how to work in a Linux environment. In particular, all on the command line. This is not an unreasonable assumption, given that we're talking about DevOps. So you'll be using the command line a lot, and you'll be working on Linux servers a lot. If that's not you, then as far as this is concerned, you're shit out of luck. But given that this is the standard on which I'm going to base all of the several projects that I'm going to be working on, it is what it is. We can probably talk about how you can set this up for other environments as well by picking and choosing the bits that you need. But for now, let's just walk through. Okay, so the first thing is this is the documentation for the base VM as it currently stands. It's very starting point, but it gets you going. So let's. This presupposes you want to develop. If all you want to do is use the environment, then really all you need to do is just use Vagrant. So we'll do it both ways, as it were. So the first thing we need to do is actually go to the repository. In fact, I've got it open in a different window. So let me just, so we can see it. Oh, come on. There we go. Okay. So this is the developer VM as it currently stands. So as with all of these things, what we need to do first is clone it. So I'm going to do it over here. And we're going to git clone. Now I've got it set up to, I've got my SSH key set up so I can actually check this out for development. It's exactly the same. So if you want to check this out, just read only, you can just use this HTTPS. If you want to check it out for development, which I won't be able to at the moment because I'm the only one authorized to do it. Let's just do this. So, oops. So if I now cd into the developer VM, so the first thing we want to do is have a look at what we've got. The main thing we've got here is the Vagrant file. So let's just have a quick look at the Vagrant file. There's nothing particularly groundbreaking about this. I'll tell you what, let's there's nothing particularly special about this at the moment. The only thing that you might need to change is this, because if you've already got, if you've already got a concourse port mapped onto your local host, then you'll need to change the port number. I have, so I do. Now then, there's nothing particularly rocket science about any of this. I'm going to change that to a raw Debian, but for now, this will do. Yeah, so all I'm going to do is, all this does is, this makes sure that the 8080 port on the machine we're about to create gets mapped to this concourse port that we just set up here. Okay, and it just allows me to use a web browser on the host machine to access access the concourse interface. That's neither in or there. I'm going to give it 8 gigs and 4 CPUs. All this magic here is just about copying files up to the guest. Okay, and this last line actually runs a shell command, which runs this provisioning core. Okay, and we will we'll take a look at that in a second. Okay, so if we just look at the so this is what the provisioning looks like. It's all salt based. Now, it's worth mentioning that Vagrant does have a salt provisioner, but I'm not using it here. I'm actually using a dedicated script to do all of the installation, and there's several reasons for that. First of all, it needs to be installed in a number of phases for various technical reasons. But more important than that, I want to be able to use the same script to do all sorts of other work, like configuring cloud servers and stuff like that. So I want it all to be the same. So in order to do that, I need to basically decouple as much as I can Vagrant from whatever environment it's going to run on. So if I relied on the Vagrant salt provisioner, then I'd be tied to Vagrant, whereas having a script that runs and actually installs salt separately, that allows me to do to generalize a bit more. Okay, so the bits of interest here are this salt, which has all of the core configuration, and this here, which is called the stack. This is because I use the stack pillars. It's an old habit. It does have a good reason for using it. Principally, one of the main advantages of stack pillars is that you can refer to pillar data which has been instantiated earlier, whereas if you use the raw salt pillar, you can't. You're kind of stuck. And I wanted to be able to, not so much in this configuration, but in general. So I've kind of got it used to using the stack pillar. And when you use the stack pillar, you have these config files. So if I just show you one of those, base provisioning stack, stack 3. Okay, so you can see these are very simple beasts, and the way the system is configured, we'll show the installer in a second. These stacks are numbered 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can then dictate the load order, which has more significance when we come to talk about projects. But for now, all you really need to know is that we're going to load this base core and this core salt, which allows us to load, for example, the base core, okay, which tells us that this machine is going to have the roles developer and builder, and the salt one. This tells us what formulae we're going to map into this virtual machine. In this particular instance, we only need one, Docker. And this is extremely simple. Docker is the name of the formula as it's going to appear in the file roots, and this is the URL the repository that we want to use to get this Docker formula. In actual fact, everything inside this Docker dictionary is really just the same as what you would use in a git.clone state. So we'll show that again a bit later. Right, so you've got the developer VM cloned. Now, if you're just intending to use this to if you're just going to use this as is, you just use vagrant up, okay, and that will then start to do all the magic of setting the machine up. If however your intention is to actually do some development work on it, then there's a bit more work you need to do. So once you're in the developer, what you need to do is you need to use Poetry to install some bits of the oops, here we go. Oh, it looks like I've already got something mapped to that 3.9. Okay. Let's change it to 3.5.6.9. Okay. That's interesting. Weird. Oh, maybe this is because I installed it earlier. No, this is probably because I installed it earlier. Let's try it. That's sure. Okay, so if I now do the next bit, which is recommit install. This is probably been done as well, but okay, so we need to do those steps because that sets up, first of all, the Poetry steps, Poetry install and Poetry shell. The Poetry install installs all the dependencies. Poetry shell puts you into a virtual environment. And the reason for that is that most of the tools that the host development environment uses are Python based. So it makes sense to just install them locally in a project. So in this case, the key ones are, I use Commitizen for commits. I use pre-commit for various hooks when using Git. And I guess that's it really. So now we're in a position where we've got the Git all set up with the pre-commit hooks. So that's it. That's now all set up for development. Now, when this machine is constructed, once the default sort of script is once the default virtual machine is set up, it then it copies a load of files across. In particular, it copies all of the base provisioning scripts. So it copies all of this stuff across to temporary directory. Okay, and then it invokes this provisioner core. Okay, and this just runs through and does things like this. It installs the SSH keys if they're available. They're not in the developer VM. These are the SSH keys necessary to access any Git repositories on the guest machine. It then installs Salt, okay, and that is just this, okay, which basically runs the Bootstrap script for Salt. Okay. It then installs, now this gets a bit confusing, it installs the Salt configuration, okay, for each of the various scopes, okay, and the scopes are actually passed in from outside. Well, okay, they're actually defined as a base, project, and personal in that order. So base is the base configuration, project is any project specific configuration, and personal is for your own personal configuration if you need to put one in. Okay. It then installs the Salt config. Now that's the actual minion configuration. Okay. So in this case, it first of all sets up this grain for the concourse port. It copies across a sort of basic minion configuration file, which is absolutely nothing special. Then it copies across these minion D. Now, if you don't know, okay, any file in minion.d that ends .conf is loaded after this minion file. So it loads minion, then it will load each of the configs from minion D. And that just gives us a nice neat way then of differentiating these. So for example, this one, we first look at the states, which have been copied across. And what we do is we iterate across that and we add to this state file routes.conf. Okay. This just makes sure that if one wasn't copied across when we copied across minion D, we create one and we put the file routes base in. Okay, and then for each of these states, we write out a line to the state file routes just to make sure they're all mapped in. We do similar sort of thing with pillar. Okay, so the pillars get mapped into the pillar routes. Okay, and stack gets mapped into stack. Yeah, so nothing particularly clever. Now you'll notice that one thing that's missing from here is formula. And that's because formulae are going to be done as part of the Salt setup. Okay, so the next thing we do is after we've got the basic configuration in place, we install Git and we use Salt to do that. Okay, oops. Okay, so we just call Salt to install the package Git. Okay, then we install the Salt formulae, and this is what I was talking about earlier. We don't write them in as part of this script. We've actually got a Salt formula to do it. I suppose in theory we could, well, no, we can't do the same with Salt config because the Salt config gets the state file route. If it doesn't have the state file routes, it can't find the states. So it wouldn't be able to find, for example, it wouldn't be able to find any state that we wanted to use to install the Salt formula. All right, like this. Okay, because all we do here is we just take the state for.salt.formulae and we just apply it. Okay. Okay, so we can actually look at oops, no one, we want paste. Core Salt formulae. Okay. And So what this does is it reads in this pillar, the salt formulae pillar, the one we looked at earlier. Okay, and then what it does is it makes sure these two directories exist, and then for each formula in that formulae pillar, it will create two stanzas. One which just clones the Git, okay, and this bit of magic here makes sure that anything we specified under the formula dictionary just gets written out here as YAML. Okay, and this one creates a soft link, okay, between formula path and the formula cache. In other words, between what we've specified as the root, okay, the file root for formulae, and the cache that we've just checked out or cloned our Git repository into. Okay, so it's fairly small bit, fairly simple stuff. Okay, and now we install Dockerpy, Docker Compose, and we then run the high state, which makes sure that everything runs as it should. Okay, so you can see here that when we run the high state, we get 45 they're not actually stanzas, but they're 45 installation steps are run. Only 16 have changed, and that's because the vast majority have already been run as part of this script over here. Okay, so as part of this, when we've done things like install Git, we've installed the salt formulae, we've installed Dockerpy and Docker Compose. Okay, all of that stuff has done part of the work that is in the salt high state. The net result of all of that is that now, having now run all of this, okay, and it's all run successfully, you can just do Vagrant SSH. Okay, and we're now in a development environment which has already got some certain things installed. Okay, like Fly, for example, which is the command line interface to Concourse. Okay, so that's an awful lot of work. It takes quite a long time to build. So what the next step is for me to write a Packer file, which will allow me to put this into a box in its own right, so that all downstream projects can just use this as a box. Okay, and we don't need to worry too much about its configuration. Although this configuration will be supplied as part of the downstream configuration. It's all going to get a bit complicated, but basically we'll speed things up a bit by not having to run all of these commands all over again. Okay, we'll be able to just take a box, which is this already built Vagrant machine, and use that as the starting point for any projects. And that should speed things up a bit. Okay, and that's basically it. There's no rocket science. Oh, the other thing to show you is inside this Python environment. The other thing you can do is you can regenerate the documentation by just going into the document directory and typing make HTML. Okay, and it will rebuild. It will just rebuild the documentation, and that is just this documentation at the moment. But that will get filled out. I'll probably end up having to write a fair bit, especially about the way the relationship between Packer and Vagrant, and I'll try and document all of this. I ran into a bit of a problem in that I wanted to actually have the brain's gone blank. What were we talking about? I was talking about oh yeah, I want the documentation to automatically do an auto docs basically on the YAML and on the salt states, which are basically YAML, and on the bash script. The problem is that there is no auto doc for bash script, and although it would be fairly simple, I think, to write one. The YAML, there is a YAML auto doc, but I had to rewind Sphinx to a version 5 because it's not yet compatible with version 6. So there are several jobs there if I wished to pick them up. Okay, one is to get the YAML auto docs to work with Sphinx 6. The other one would be to write a bash auto doc, which would be quite useful. I'm not minded to do that at the moment, although I did have the idea that I would be able to use TreeSitter to write a more generic auto doc. It wouldn't be great because obviously there would be certain shortcomings of anything like that because it would be limited in exactly what it could detect. But by using TreeSitter, you at least give yourself a fighting chance. So yeah, maybe that's an interesting exercise for the future. But for now, completely off topic, I will just manually document them for now. I mean, the other possibility, I guess, is to write a simple awk preprocessor for Sphinx, which would generate some pages to be included and just pull comments out of a bash script. Yeah, maybe that's the way to go with it. Because I mean, that's really all the autodoc does with YAML. It does a little bit of syntax. I got rid of the example I did actually, but the YAML autodoc understands certain indentings and structure of the YAML file, and therefore can produce document with correct indenting, and it can control levels. So that's kind of cool. With bash, we could just look for a particular comment structure and just pull those out and turn them into Rust. And I suppose we could also look for... See, the problem is that bash is kind of limited because there's no concept really of a signature for bash functions. So you can't really automate very much in terms of, you know, pulling out interface functions. So it would all have to be done in comments anyway. So yeah. The nice thing about having the documentation in the code is that it's easy to see if it's up to date, or easier to see if it's up to date. But bash, it doesn't really lend itself to that. But another thing that's worth actually going over while I'm here, if I look at this script, you'll notice that at the beginning, I've been a good boy and put in certain things at the beginning to make sure that they're all sort of part of the standardized stuff. You'll notice we're using shell check to check it. Okay, and if we go, if we go down to the bottom, you'll notice that down here I'm not using anything to protect these function calls. Normally, with a normal bash script, I would have a thing that checked whether bash source was being run directly or as an inclusion, so that I could then write tests. But in this case, I've been lazy and I've just said, nah, fuck it, I'll you know, because a lot of the tests for this would have to be run on the guest, and I'm going to do that a slightly different way. We're going to use InfraTest, I think. Test infra. I always get it the wrong way around. To actually do some infrastructure tests on the machine, which is different to testing the script. But given most of the script is about configuring the guest, we might as well just run tests at the end to make sure we've got a shakedown. To be perfectly honest, if the high state runs through to completion, you're pretty much guaranteed to have the right thing. Okay. So that's it. I mean, that's what the last few days have been about. Nothing groundbreaking. Like I said, a lot of the time I've had other things to do. It's only been a few hours work, but it's coming together. What other things are there to talk about? Oh, yeah, talking about what's in the I suppose I'll go back over here and okay, so we're in the root. If I okay, so we've got a few things here. This is the committees in, and you'll notice that the only thing special about this really is I've extended this to update the conf.py for the documentation. So the documentation release always matches whatever the version of this is. So when we use CZ bump, it will automatically change the documentation as well. So that's nice. I'm going to look into getting the documentation produced in a read the docs form, which I can then, have the classic pull down. You can see older versions, so that when these things get, when these builds get tagged as the CI/CD process gets instantiated, as these get tagged post build and the artifacts go in the repository, one of the artifacts to go in the repository will be the generating documentation. Those can then be put on a sort of read the doc style website and made available. Yeah, so that's the idea behind that. The other one is pre-commit. Okay, and again, this is fairly vanilla. Actually, I don't need to exclude anymore because I've changed the way they're done. Could actually change that. Let's do that now. While I remember it. So in actual fact, we don't need that. While I'm here, you'll notice that the repository. Okay, so what have we got? We've got the end of file fixer and the trailing white space. That's really just sort of good management of files. You don't want extra end of lines. Extra lines in your file, and you don't want weird white spaces at the end of a line. Then you've got committees in, and the main thing that's doing is making sure that my commit messages all follow a predetermined format, which really the first line is the key. It needs to have something like FEAT for feature, or fix for fix, or docs for doc, because those are indicators to the committees in bump about whether or not it should do the major minor patch number. So yes, so it's important that those get checked. The other thing it does is it does this YAML lint, and you'll notice it runs YAML lint across the YAML files and across SLS. And what that means is you have to be a bit careful when you're mucking about with SLS files that anything which contains YAML, like for example, like this, because it's got YAML in there, you have to tell YAML lint to ignore it. And this is what I was going on about the other day. It's a bit of a pain. Because the open curly brace percent sign is actually a syntactical error in YAML, YAML lint can't cope with that. There is another way I could do this, and that is to lint the processed version of the file. And that's got some merits, because all of the comments could actually also expand out to have correct names and so on. And there is some merit to that, which would mean that the Sphinx would have to have a preprocessor, which would take these files with embedded YAML and then use Salt to actually expand the Jinja. So you ended up with just a pure YAML file, which you could then pass to YAML lint. You could pass to YAML lint, or you could pass to Sphinx, the documentation. Or YAML lint's got nothing to do with Sphinx, but you know what I mean. It basically anything that's expecting pure YAML, in other words, passes it through the YAML parser, would need to be pre-processed, because otherwise the Jinja will just call it for a conniption fit. Okay. Okay, so yeah, is there anything else? I think so. I'm very uncomfortable, Kenny. Pre-commit, git ignore, base. Oh, the PyProject.toml, but that's just a standard TOML file for used by Poetry. And you can see here, these are the tools that are installed into the development environment. So you've got committeezen, pre-commit, YAML, lint, and Sphinx. And these are the ones I was talking about. I've got most of these installed in that's interesting. Why is it Sphinx 613 in there? Oh, it's because I haven't committed it from earlier. Yeah. What was that? Right. Okay. So to leave the virtual environment, just exit, and we're back then to the top level. So okay, so we've got the pre-commit. I just changed. Which was just to remove the that formula line, because we no longer embed those. They used to be actually embedded in the base. So they used to be embedded in amongst this lot. Yeah, there was a directory at the top level called formula. The problem with that was that they got big. It was totally unnecessary. So I got rid of it and changed it to this new method where it on the guest, it actually clones the repositories into a cached area and then links them in. The reason for that, by the way, is to do with the structure of these of a formula project. So if I no, not that. Okay, so here you can see this. This is actually linked to the formula cache, and it's linked to that second level directory. So you've got the Docker formula, which is actually what gets that's the actual root of the cloned repository, and the Docker is within that. Okay, and it's conventional. So So here, okay, you can see this is what gets cloned out. Okay, and you can see it's got all of the usual stuff surrounding it. And the only bit we're interested in is actually this bit. Okay, so you can't just we don't want to just take the formula and write those out into /server/formula, because if we do, it will confuse the hell out of everything. It won't be able to find it. So we do this funky trick with linking the directory into the formula cache. And what it means is that when we look at this, nope, when we look at this, okay, we just need to put that one directory in. Now, in this particular context, that's not hugely important. In the context of running it with a master, that's actually quite important, because we can now arbitrarily add formulae without having to constantly restart the master. Okay, we've added the specific directories in at this level. Okay, because the other way, often, or the way it was done before, is each of these lines would be, if we cloned directly into formula, then we would have had to say something like, do you know what, Kenny? You don't make this any easier, right? We would have to say Docker formula in there as the root. Okay, so the directory underneath it was Docker, which is what we were looking for. We'd have to do that for every single formula. The problem is, what you then end up having to do is in a master minion setup, you would have to restart the master every time for these file roots to be reread to get the new formula installed. By doing it this way, you don't need to do that. Anyway, that's just a minor thing. Right. Don't need that anymore. That's what happened before. I've left the virtual machine running from when I was testing this, and that's why I ended up with the port collision. Right. And that's it. That's the show and tell for this evening. So I'm going to love it and leave it. I'm off to go and watch some old MASH.